Right, so next we talk about two-way sensitivity analysis using numerical analysis. So as we discussed before, changing the value of pp from 0.1 to 0.5 doesn't change our decision. So our final recommendation for treatment is still using AC option. However, now we may ask, what if our recurrent PE of a no AC option is not 0.25? In other words, is our decision changed if the value of PP is not 0.19 and P of FPE? That's probability of a fatal recurrent PE when the no AC option is selected and it's not 0.25 anymore. So in order to answer this question, we will perform two-way sensitivity analysis by changing the value of two variables at the same time. Particularly, we're going to change the value of PPE and PFPE at the same time. Look at the tree right here. You're going to vary these variables and vary this variable at the same time. When you vary this one, this value also changing as well. And similarly, the survival probability will also change as well. So we'll go through the main step in as in one-way sensitivity analysis in order to perform the two-way sensitivity analysis. So the one of the steps we need to do is that identify the plausible range for each of the variables. So here we assume that the PPE curve from 0.1 to 0.5 and P of FPE from 0.2 and 0.4. And for each of the pair value of the PPE and PFPE, we're gonna calculate the corresponding expected value of survival probability of two options, AC and no AC option, based on the constructed tree right here. Okay. So how can we do that? In order to doing that, we're gonna do changing the variable. First, we're gonna select one of the variables. So let's say we select the variable PPE and select the very first variable in the range. So that's gonna be 0.1. And second, we vary the value of PFPE for the entire range for this variable. So we saying that the PFPE from 0.2 to 0.4. So we gonna keep the same values for the PFPE 0.1, but now we're gonna change the value of the PFPE right here. For each of the row right here, we can recalculate the related probability and the expected value for each of the row. So particularly, we gonna calculate the expected value of this one right here, and then we calculate the expected value for this option and this option over here. Okay. So let's consider our first row in the example right here. In this row right here, we have the value PP equals 0.1. From there, we can calculate the probability of the no P equal 1 minus 0.1, 0.9. So this one 0.1, 0.9 right here. The first row right here, P of FPE equals 0.2. This is a fatal P right here, 0.2, so we can calculate the survival probability equals 0.8. This 1 minus 0.2. Okay, so we have all the value updated in the first row right here. Sorry. The next step we gonna because the calculation of the expected value right here gonna depend on the expected value right here. So one of the intermediate step right here, we're gonna calculate the expected value of one fold right here, based on the new value of the fatal PE and survival right here. So this one right here can be calculated by 0.2 times with 0 plus with 0.8 times with 1. So that's 0.8. So we can update this one right here. Given this value have been calculated, we can calculate the expected value for AC and no AC. So for the AC option, we can do the same. Equals 0.1 multiply with the expected value right here, 0.99 plus with 0.9 times with 0.992 right here equals 0.9918. Similarly, we can calculate the expected value of no AC option right here equals 0.1 times with 0.8 plus with 0.9 times with 1. So that's equals 0.98 right here. And based on the expected value of AC and no AC, we determine that the optimal decision for PP equals 0.1 and PFP equal 0.2 is AC, because AC option have a higher expected value survival probability. We apply the same process for the following rows, and we also end up with the optimal decisions AC. Now we knowing that just one single point of PPE and P of PE gonna be from 0.1 to 0.5. So we need to change to the next value of PPE while we're gonna keep the same range for the PFPE. So look at right here, we're gonna increase the value of PPE to 0.15 for the whole range of the PFPE, and we're gonna do the same calculation, and we're gonna determine what the optimal value of optimal decision for a new value of PPE and PFPE. So all the calculation pretty the same, and I'm gonna show you in a minute through the Google spreadsheet in order to how to construct the table, how to put the number, how to create the formula to calculate, and also determine our optimal solution. Okay, and in the slide you can download the Google spreadsheet have been provided, so you can study and so can use this for your future group project. All right, so in summary of the content for this week, so which we focus on the following main objective: this understanding one-way and two-way and n-way sensitivity analysis. Why do we need it for the decision-making process? And then we utilize the Google spreadsheet software to perform the sensitivity analysis for one-way and two-way analysis. And then we determine how the sensitivity our decision is with respect to the estimated values. Particularly, we interpret how our final decision going to be concerned or not concerned based on the reversal point, how far that compared to the estimated value we use in our calculation for the decision. So we also note that for n-way sensitivity analysis, we can apply the same approach, but it's obviously much more complex, and within the scope of this course, elective course, we can focus on one-way and two-way sensitivity analysis, right? So in the last video, I'm going to show you how we do the two-way sensitivity analysis using Google spreadsheet.